A very common example of an annuity would be saving for retirement. Most people will choose to put aside money every year to save up for retirement. So let's do an example here. We have Darren and Marin, who are twins. They did everything together except for how they chose to save for retirement. Retirement age is 65. Darren saved $1,000 every year since he was 25. Marin saved $2,000 per year since she was 45. Both of them invested it at 8% compounded yearly. So, 3 questions. At retirement, how much did each twin contribute? Part B, how much money will each twin have at retirement? And part C, why does one twin have so much more money? So, since we're doing a comparison, I'm going to separate my paper into 2 halves so that we can have one side for Darren and one side for Marin. So part A, we know that contributions would be the amount times the number of times they contributed. So Darren saved for N 65 years minus 25. Darren put in money for 40 years. So we have $1,000 times 40. That gives us a total of $40,000. Marin, on the other hand, has contributed since she was 45. So her N is 20, but she doubled the payments and she ended up contributing $40,000 as well. So we know that both of them at retirement have saved $40,000, except that the way they saved it was different. Darren started earlier when he was 25, and Marin started when she was 45. So let's find out how much each twin will have at retirement. And we're going to use our annuity equation. So just a reminder, our annuity equation, we have R times 1 plus I to the power of N minus 1, all divided by I. So we know that our R for Darren is 1,000. The I is going to be the same for both of them, 0.08%. And since it's compounded yearly, we don't have to divide it by anything. And we calculated the N already was 40. So the amount for Darren, 1,000 times 1 plus 0.08 to the power of 40 minus 1, all divided by 0.08. Okay, so we have, 1,000 times 1 plus 0.08, close bracket, to the power of 40 minus 1, close bracket, all divided by 0.08. So at the end, when Darren is ready to retire, he has $259,056 and some change. Now for Marin, let's sort out the information that we have for her. Marin contributed $2,000. Interest is the same, 0.08, and N is equal to 20. So let's fill out our equation. We have 2,000 times 1 plus 0.08 to the exponent 20 divided by 1, or sorry, minus 1 divided by 0.08. Let's throw this into our calculator. 2,000 times 1 plus 0.08 exponent 20 minus 1 divided by 0.08. And Marin only has 91,230 and 93 cents. Well, that's a significant difference between Marin and Darren. So going back, what part of the equation do you think made the difference? Now we looked at the R. We said the R didn't make that much of a difference because the R regular payments both ended up giving us a total sum of contribution at $40,000. The interest rate was the same, but the main thing that was different was the number of years. Now remember that we said exponential functions grow fast. Once it gets growing, it grows very fast. So the longer that money is in an account, the faster it's going to grow. So why does one twin have so much more money? So Darren has so much more money because he started saving earlier. And this is an exponential function. And you remember that if we were to graph an exponential, it starts off slow, but once it gets big, it starts moving up very quickly.